In this video, I will be describing the first step towards a convergent total synthesis of the natural product Lindbergin E, a molecule with both a unique, unexplored fluoroglucanol backbone and potential Lieshmanicidal activity, Leishmaniasis being a neglected tropical disease in which treatment options often have very high failure rates, sometimes up to 50%. In this first step, I will be synthesizing the 5,7-dimethoxy 2,2-dimethyl 1,2H benzopyrene intermediate required for the preparation of fragment A, one of two fragments that will be brought together in a final coupling reaction to form the final product, Lindbergin E. I will be scaling up a protocol published in the Journal of Organic and Biomolecular Chemistry by 20-fold. The protocol uses a unique phenylboronic/benzoic acid co-catalyst system using 3,5-dimethoxyphenol and prenal as starting materials. The original protocol called for a 97% yield on the 0.5 millimole scale. First of all, a reflux apparatus was prepared using a standard round-bottom flask and Liebig condenser. Next, a stirring plate was placed under the heating mantle to ensure an adequate mixture of all reactants. Lastly, while not mentioned in the original paper, a drying tube was used on the top of the apparatus to ensure a moisture-free environment. The powdered reagents were first added to the reactant mixture. This included both the 3,5-dimethoxyphenol and the benzoic and phenylboronic acid catalysts. Next, the 50 milliliters of heptane, along with a PTFE stir bar, were added to the flask. After all the reactants were dissolved with consistent stirring, the 3-methyl-2-butanal, or prenal, was transferred to the flask using a rubber septum and a syringe. The reaction was then heated to reflux with moderate stirring and run overnight for a total of 17.5 hours. After the reaction had run, it was confirmed to have been complete with thin layer chromatography, or TLC, and a 4% ethyl acetate and hexane eluent. Excess solvent was then removed with the rotary evaporator. A 50 mm diameter column was used since more than 3 grams of crude product was being purified. 60 angstrom, 230 through 400 mesh silica gel was used to pack the column using the wet packing technique. After the sand layer was added to protect the silica gel, the crude product was carefully added with a Pasteur pipette. And then 500 milliliters of the 4% ethyl acetate and hexane eluent was prepared and loaded in the column. A small pressure regulator was lastly used to push the solvent through the column and into 7 milliliter fractions. Each of the fractions was run on TLC to determine which contained the final purified product. And then lastly, the purified fractions determined to contain the product were placed in a round-bottom flask and run on the rotary evaporator and dried under high vacuum to remove traces of water. Both proton and carbon NMR, along with IR, were run to confirm the identity of the product. A very clean spectrum was obtained, which is consistent with literature. You can also see that at about 77 parts per million on the carbon NMR, there is a triplet. That is consistent with the CDCl3